Hi, welcome all to Code Without Barriers Hackathon 2026 ASEAN edition. Today we are gathered here for the problem statement sharing session. It is with the iNextLabs. Over to you, Darun, to take all the participants with the problem statement shared by iNextLabs.
Yeah, thank you, sir. So, hello everyone. Very good evening. I'm Darun, engineer from iNextLabs. So, let me give a brief about our problem statement. Before that, let me share my screen. I hope my screen is visible, right?
Yes.
Yeah, okay. So, hello guys. So today we come up with a problem statement, which is a real world problem that many of the big catering companies have been facing right. So we have come up with an AI-powered multi-agent system so that you guys need to be developed. So the problem statement mainly emphasizes like you need to build a multi-agent system that automates the end-to-end operations of a catering operations. The solution should simulate a digital team of specialized AI agents collaborate to handle end-to-end catering workflows. So from the customer interactions, like what are the requirements they need, how much orders they require, and then the focus on the real world applicability as well. So this is a brief overview of the problem statement. So let me dive into the real world scenario. Yeah, hope you can see my presentation here. Okay, good. Sounds good. So I've been break down this entire phase into four sections, which is one a foundation and problem context. What is the problem that we are facing actually in the ground reality? That's the first one that we are going to see, and then the how understanding the multi-agent, how our multi-agent systems is going to work, and then how we need to develop each agent for this respect to this catering operations, so that all agents can be talk to each other, and then and then they can work to the final goal, right? And what frameworks that we can use and how the workflow will be there. So let's dive into the foundation of the problem context. So, first, what is the big disadvantage, or what is the big issue or problem that they are facing catering? So when we say catering, most people we just think of food. But as a developers, we want to look deeper, right? So when catering is a high stakes of real time logistics, and it also involves a lot of math problems as well. So today the industry in chaos for catering, because it's a manual. Everything from the requirement gathering to the inventory management and much more, like the sudden spike of the guests, everything is in manual, right? So requirements are trapped in messy WhatsApp chats as well, and in sticky notes and somewhere in a pen and paper, so on so. So there are chances of data getting lost, and we see there is a lot of waste gap as well, where 30% of food and money is thrown away because of a poor estimation and not because of proper planning as well. And the worst part, there is a disconnected logic. So if a guest count suddenly have some changes on Friday event, the grocery list will not be updated till the last minute. So this is a mess. We are here to clean up with the code, right? We clean up with the intelligence. So yeah, so now you can ask why do we need a multi-agent or an AI to perform these tasks? Why can't we just use a better application or a software any other software? So, but with the traditional applications, these are siloed because they are one-man bands. So that's the only one thing, one person or one static database will be there and has to handle every update. These systems are reactive, so they tell you what went wrong only after the event or the management event will be after event is over or get ruined. So in this hackathon, so we are moving away from the folders and files and then the single databases and moving towards the building of intelligence. So with to build a smart scattering, we need a multi-agent revolutions. So as I said before, we have the gap that a single application won't be enough, right? So here we are not building an application. So we are building a digital workforce which can able to interact with each other like human. Let's say there are 10 humans. Instead of 10 humans, let's say there are 10 agents. They have each task allocated to them, and then they will interact with each other of them, and then they will work towards a final goal. So this revolution of multi-agent systems. So as I said, imagine a team of specialized AI agents. So they don't just take orders, but they will also negotiate and communicate. So system where the kitchen and the office and the delivery van are all living in the agents. So here we are going to use the Microsoft Agent Framework. So they talk, they sync, and they solve the problems before a human even notices them. So yeah. So right now, you guys have something in your mind. So by doing this, by taking this problem statement, what problem that you are going to solve, and what are the opportunities that will be open in our market? So the opportunities by solving this problem is massive. So we enable zero waste logics. Even though if we couldn't achieve the zero waste, we can achieve more closer minimal waste logics, and we are talking about a 20 to 30 percentage of increase in profit margins as well, just by building a smart intelligent agent. So you are building a systems that allows a small catering businesses to scale like a global chain. So you are just not just hacking, like just not just developing any other applications. You are re-engineering a multi-billion-dollar industry. So now comes on to the section two. So which is understanding why do we need a multi-agent systems. So let's get more a little more technical. So you guys can think we can solve this entire system with a single agent. Why do we need a multi-agent? What's the need for that? So let's say if you are building a single agent, you have to give a huge prompt. Let's say you are using any updated model or any latest model. Let's say GPT 5.4 Pro, Cloud Sonnet Opus 4.6, any other updated models. So which has a lot of larger context windows. So you are going to give a one gigantic prompt to that particular model because of the context overload. If you ask one AI to manage all these things, so it basically, if you think from the management perspective, it has to manage the order requirement, then the invoice processing, then the requirements for the things to prepare, like the groceries, other stuffs, and then the quotation generation, and then if there is any sudden spike of customers or a sudden spike of guests, that should be also managed and that should be also updated on all the related inventories so that everyone will be aligned with the what's the exact requirements and what they need to work. So if let's imagine if do you think whether the single LLM or a single agent is able to do these kind of stuffs? Definitely not. So what it will does, it start feeling overwhelming and it starts going to hallucinate and it loses a focus. So that's why we need a multi-agent team. So multi-agent team in the sense each agent will have a specialist. So each agents are one specialist. So by giving each agent a narrow specific goal, we get a high accuracy and better memory and faster processing. So it's the difference between a solo intern and a team of senior executives. So hope you now understand why we need a multi-agent system. Let's say an analogy. So think of your code as a digital boardroom. Okay. So there is a chef agent proposes a menu, right? So a chef will be proposing a menu. The accountant agent sets a budget of that particular menu. For example, in that menu, they are using a lobster. And according to the accounting agent, The accounting agent main task is to keep everything in a budget from the user's perspective. So the accounting agent will be checking that the lobster is too expensive, and they may use some other alternative, let's say sea bass, something like that. So the logistic agent chimes to into say, wait, sea bass needs a refrigeration, and our refrigeration will be everything is full. So they negotiate that. So if you see here, it takes place the whole human part from the start of the menu, and what ingredients that they are using in the menu, and they are also comparing those ingredients with the budget, whether it is aligned with the budget. Then even though if it is balanced with the budget, they are proceeding with that. If not, they are going with an alternative. Then even though if they are going with alternative, they are thinking about the storage of that particular alternative product. Here, in this case, CBs. And then whether they are also thinking whether they have a space for that particular product to be stored in a refrigerator or wherever else that required. So all this human like process is doing is capable of doing with these kind of multiple agents. So they have this handshake, this consensus is where the magic happens. Only with the interactions between these multiple agents we can achieve this type of we can solve this type of problem state or the real world problem. So here, as a participant, your job is to facilitate that conversation. That's the main important thing of this problem statement that we are going to see as well. Then, so I will give a little bit brief about how the multi-agent system architecture will be there. So there will be an input layer where we will be getting the requirements from the end user. So as a user, here user is will be the person who is going to give order, right? Order for a catering. So they will be saying, for example, they may say, I need 1,000 plates with some, these are the dishes, and my budget is this, and my preference is this, and these are non-veg, veg, so on, so on, so on, so on. So, and particular in the multi-agent architecture system, we need an input layer. Then we need to get into the intent agent. So intent agent is that, let's say we gather all the requirements, budget, preferences, much so on. Then we need to the particular agent needs to identify what are the things that we need to do as a next step. First, it needs to prepare a menu. It needs to prepare the requirements. Requirements in the sense, what are the things required to do these dishes, and then it needs to check with the budgets, and then it will needs to confirm with the user. Then it needs to update the inventory and check with the inventory as well, and much more other works has been also included. So intent agent will separate all the requirements and pass it to the particular agents. Particular agents, as in if you see in the step three, we have a specialized agent. So it will be passed to each agent, like it will be so all the information that are necessary to each agent. Let's say if you are going to accountant agent, it will be passing the prices of all the ingredients that required to do this dishes. Then if it is, then it will pass the quantities that are present in the inventories as well as the things that need to be by so and so. So it will be intent agent is responsible for segregating the work and then passing these works to the particular agents. You can think of it like a manager. If in a company we will be having a product manager, project manager who will be able to handle an entire project by allocating each particular task from to the different divisions or different peoples. Same kind of principle that we are going to use in the multi-agent architecture as well. Then, if we come on to the step four orchestration engine, so basically that's what here plays the synchronizers comes. So each agent will talk to each other. For example, if the project manager gave allocated the tasks to five people, the five people will be able to collaborate each other and they resolve their dependencies on each and then come up with the final solution. So that's what here orchestration needs to be developed. Then once we develop, should we leave like this, like as it is? No, definitely not. So we need to execute and then monitor those developments and runnings. So each runs we need to monitor whether it's executing 100% accurate or if a system needs to be optimized more or not. So this is a basic building blocks of building a multi-agent system architecture. So let's see now how we need to build our agents. Like what are the personas? Let's say I will explain more about on the personas with respect to our problem statement, and then you can take it from. So here what I'm seeing is for this problem statement, I'm seeing five core agents. So here need not to be exactly five. You can also develop more than five agents by breaking down the task. That's up to you. But these five agents are much more and much needed to do these tasks efficiently. So the concierge agent will be passing the guest preferences. As I said, if you relate with this slide with the architecture, you can relate. You can get a good picture of this. So the concierge agent is for intake, and then the chef agent for creating the menus, and then the accountant agent is for checking the inventories and then the budgets and so on. Then logistic agent is for like plans for the timeline, how much time it will take to deliver this particular product or requirements also. And then the stock manager will also be able to check for the inventory as well. So as you see here, each agent can maybe overlap with each other so that you can develop based on the efficiency and accuracy, you can split even more agents, and then you can make them collaboratively work for the ideal problem. So here, sorry, yeah. So here, the main important thing is that we need to define a clear agent boundaries and handoffs. So when this particular agent needs to be invoked and what does it needs to do. So one agent shouldn't do the another jobs and shouldn't mess with each other. Then the final outcome will be definitely only satisfaction, give the satisfaction to us. So we need to clear agent boundaries and handoff specialist focus and simply drive system perform effectively. So till now we are talking that we need each agent needs to be communicate each other, right? So you guys may have some doubts that how each agents will be communicate each other, whether it is via text or does we need to use any other protocol. So there comes some ACP protocols. You can use any other ACP protocols. So here you can see that you should be using a JSON-based format, which consists of header, payload, and metadata, and then audit trails as well. So that's known as a signature, so that you can able to identify if any issues comes with that particular agent or a hold. Okay, you can easily able to identify which agent did the mistake and where it has been failed. So that's why here it is much important rather than make the agents to talk with each other in a series of text languages. Instead of that, if we make them talk with based on the JSON based format, which will be more efficient, and then the standard way of agent to agent communications. And then if you see the graph, so when each agent will be working on their particular task, there is an involvement of data complexity. So if you, in the graph, you can see that what is the involvement of data complexity on a rough, like for concierge, what kind of data that has been used on accountant agent, what kind of data that has been used on logistic lead, so and so. So there is also another important thing where you need to focus on the data part and how the data is being utilized by each particular agent or by the whole agent. So then comes the Microsoft Agent Framework. So for this particular problem statement, for this hackathon, you can use the Microsoft Agent Framework with semantic kernel as well and AutoChat. So in this Microsoft Agent Framework, it can able to handle memory and turn taking as well, so that you don't need to worry much on the memory side and turn taking. And then it is also maintain it is so good in understanding the like maintaining the conversation history as well, so that each agent is able to have some context when they are working on each other, like working on a particular task. So this agent framework is also capable of allowing your agents to remember that the customer is allergic to nuts even when they are 10 step deep into logistic planning. So when during the requirement, so let's say the user is saying that I am allergic to nuts. Okay. Then we shouldn't we should where do we store those requirements. So we have to keep a memory. So this Microsoft Agent Framework is also providing those facilities. It's inbuilt packages in the memory module, so that you can store the key informations on that particular code. Then while doing the particular actions to the particular agent can able to utilize those informations and plan accordingly. So while preparing menu, in this case, we shouldn't use the nuts, something like that. So that's what the Microsoft Agent Framework is comes into the picture. And then regarding the LLM, any questions? I think someone is trying to speak. All right. So regarding the LLM, you can use any kind of LLMs that you can access, right? And then which is you can also test and trial it out which LLM is most suitable for this particular multi-agent framework, multi-agent problems, right?
Dharma, I think there's a question in the chat box.
Okay, let me look.
Do you
Okay,
want me to
regarding the
call
K,
out?
no, sorry, let me take that question. So, what are the KPIs of good catering service? So, so basically, if you see an overall good catering service, we can see they will take into mostly they will take see that on time delivery without any delay, and then there should be a plan B for accepting a more guests, so that without any misconceptions has been happened, and then with less food, less uh, food wastage as well as the food taste as well. So when comes to the agentic part that we are building, we are trying to do an operational stuff. We are trying to simplify the operational stuff, and then we are making them to help with the profit, increase their profit, and then reduce their wastages, and then reduce their last minute uh, chaos and all. So if you talk in terms of KPIs for this particular problem statement, we can say how efficiently a particular order is being handled, and how we are forecasting the increase of guests or decrease of guests, and how we are efficiently checking the managing the wastage of food as well. Yeah, on time delivery, ability to fix demand, profitability from this. Yes, correct. So when you fix all these operational chaos, definitely the on-time delivery will be happen, and then the flexibility in the demand and the profitability and reduce of stoppage will be there. Yep, that's a good question. Okay. I think there's no other question. Yeah, there's no other question. Let me move on to the next topic. Okay. So how this particular problem statement workflow can be handled. So as I said before, in the architecture itself, we need to get a user input. So without user input, we couldn't do anything. So it is like you see in the recent trending topics like OpenClaw, Cloud Cowork, so on. So what are those agents? So those agents able to do given task. This is the task that you need to do. They won't much do an interruption with the human. They will talk to each other, and they will attain the final task goal. Once the goal is verified, then it will come up to the human that say, "Hey, I did this job. Do you want me verify that?" That's a job. That's how the multi-agent should work. So we get here in this case, we are getting a user input, all the requirements, guest count, cuisine, budget, dates, so on. Then the menu should be created. So while doing a menu should be created, we need to keep in the mind of budget. So the menu should be within the user's preferred budget. Then we should also check the inventory and logistic plannings. That's what the phase 4 will be. So and then the competitive advantage. So while doing these things, we are doing make more workflow excellence, and there is a seamless agent handoff. Definitely, there's a competitive advantage for the particular company. Yep. So regarding the technical requirements and the stack that we are expecting, so it is better if the agent to agent communications which can be taken place through the JSON, fixed JSON schema. That will be great so that it will be useful to you guys as well to come detect any error or else debug the code and audit trails as well. And you guys also will get a clear understanding of how the agents has been talking to each other and how the works has been takes place. Then, regarding the technology foundation, we will be using, you guys should be using a Microsoft Agent Framework, comes with the semantic and an AutoChat. Then, regarding the LLMs, we are open to you. You guys can use any LLMs that performs good and suits for app for this particular problem state. And then the back languages, coding languages, that's up to you. You can use Python or JS, any other languages that suits you. And then databases, that's also you can use Azure services as well. So see, okay, we come with the last part of this deck. So what is the success criteria and winning features of this particular problem statement? So the main thing is that how well you orchestrate the agents. So you guys can develop this particular problem statement with minimum of 5 agents to up to 10 agents as well. That's up to you. How well the orchestration has been happened. So how well these agents communicate each other, on which condition or which criteria these agents are communicating each other. That's the first point. Then consistency. So these agents are communicating well in a consistent manner, or they are having some defaults like defects. Like one time it is communicating with every other agents properly, or else sometimes there may be some scenarios that but each one particular agent can also do all the stuff, and it will say some invoices or some final answers as well. So that's a consistency that we need to take care. And then the performance. So how efficiently you can with the minimum of token cost. Obviously when we are diving into multi-agent scenarios, there will be a blow up of token cost involved will be there. So how efficiently you are managing those edge cases, like with the minimum token cost with more accuracy. So that's what companies love a lot, right? And then the robustness, and then how well the KB has been integrated. KB in the sense knowledge base or data. So data. So the data is a core point. How well you are passing the data to each agent, and how well the RAG and other stuff has been done. And another important thing is that, as I said, there's a shared memory also. So this shared memory is among the different agents that is handled by Microsoft Agent Framework as well. So how well you orchestrating those shared memory? So because memory plays a crucial role, so with the memory only, these agents can succeed and provide a 100% accurate results that we expect. And then based on the orchestrations and based on the architecture, how well this system that you are developing, this intelligent system that you are developing will be adapted for the real world scenarios, and then how feasible this can be integrated in the real world scenarios and give it as a product to the particular catering systems as well. And then, as I said, so there's the innovation part as well. So you can see how concurrent these agents are interact each other and intelligently share the resources. As I said, with one LL, are you going to use a one LLM for all the agents, or each agent will have a different LLMs, different persistent memories or different local memories, so and so. That is up to you. We are not restricting anywhere that you need to use a one LLM or different 10 LLMs. That's up to you. How well you are innovating on this part. So that's the crucial part. And then last but not least that I want to say for this participants, this is not a chatbot that you are asking, typing hi, the agent is going to reply, hi, how are you? What's the information that you need? So and so. Not that is not that we are going to build. We are moving beyond the chatbot. In the era of 2026, we are definitely we need to move beyond the chatbot, and we need to we need to develop a fully autonomous agentic systems through multi-agents. So yeah, so that's what about this mentoring session. So if you guys any doubt or clarification, please ping me.
I request all the participants that have joined us for the problem statement sharing session with iNextLabs. If you all have any queries, you all can unmute yourself and ask your questions. If not, you can also drop in your queries in the chat box. We'll wait for another 5 minutes before we drop off from this call. We have a question in the chat box, Tarun.
Yeah, sir. So what's the recommended way to stimulate real-time logistics delays in multi-agent? So yeah, so you can create an pseudo data set on yourself, right? So with some logistic information like all the menus with these amount of quantities that has been present, and you can also define the parameters. For example, let's say in your inventory, ready to use, right? So we can you can have a keyword called ready to use so that these many items will still ready to use. Then you can also say these many items needs to be come from another inventory, which takes 10 to 15 hours of travel. So you can populate the data on yourself. So that's why we give full freedom on that part. So we are not restricting to use any particular data. So you can populate the data which works well for this problem statement. How well for that agents. Yep, thanks. Then, do we get the help in mentoring to make the product? Definitely. So we guys from iNextLabs, me, Mamlesh, and Ross will be available in the Discord channel. You guys may feel free to ping any doubts. We will be happy to clarify the doubts and help you to develop this particular problem statement. Regarding the tech stack, so primarily from this hackathon, you should be using the Microsoft Agent Framework as part of the when it comes to framework. Then is there any other tools or tech we must use? You can use other resources that are available in Azure AI, Azure services. Like you can even use OpenAI models or any other LLMs from the Azure OpenAI services, and then you can use Azure AI search from the Azure, and then what else we can be used? Mm, Translators for multilingual capabilities, much more. Yeah, you can feel free to use any other tools that are required to solve this problem.
Darun, I think we are good. I don't see any other questions coming in. I'll just wait for another 1 minute before we can drop, and we can take the questions in the Discord channel as well.
Yeah, definitely. Sarah, sounds good.
Okay, since we do not have any more questions, thank you everybody for joining us today. Thank you, Dharun and iNextLabs team to help us here with the problem statement sharing session. For any more further questions, please drop in your queries in the Discord channel. iNextLab mentors and myself will be available to answer your queries. Thank you once again for your time. Have a great day. Bye bye.
Yeah, thank you, Sarul. Congratulations all.
Thank you, Dharun.